Hello, this is Brett from SurvivalComms. Today on the bench we have a Diamond Antenna SRH805S. Now this is a VHF UHF dual band antenna and it also does 1.2 gigahertz. Now I've had this particular antenna for several years now and I bought it from AES before they went out of business, and it's a cool little compact antenna. It's not the most phenomenal performer, of course, because of its compact nature, but I mean it's 1.75 inches long. And this particular antenna is set up as an SMA male connection. Now, I bought this from a reputable vendor, AES, and to get one of these from a reputable vendor, you're going to pay about $30 for this particular antenna. So I decided I wanted to obtain another one of these antennas for another radio. Well, of course, you can go on Amazon or another source of products, and you can get two for $15, and these are in packaging marked Diamond Antenna, and they have the same kind of markings on there. You can see the packaging isn't as well made as the ones that come from Diamond Antenna, but they look very similar. So now we've got our counterfeit antenna out of the bag here. And you can see one way to tell is, of course, this little rubber ring will slide on and off with ease, whereas on the original one, it's actually adhered to this gold band and this metal portion of the antenna for the RF connector. And if you look at the markings on the antenna itself, it says Diamond Antenna. It's got the same exact script on it. And here's our legitimate one on top. Let's see where the rubber meets the road, how these counterfeit diamond antennas compare to a legitimate diamond antenna. So in examining both of our examples here, and this is the genuine one on top and the counterfeit one on the bottom, the easiest way to tell is by looking at the diameter of the center pin. The center pin on the genuine antenna is smaller in diameter than the one on the left here, which is our counterfeit one. Also, the genuine antenna, the center pin resides 55 thousandths of an inch below the body of the RF connector, whereas in our counterfeit antenna, it only resides 11 thousandths of an inch below the body of the RF connector. So let's take both of these examples, put them on some test equipment, and see if there is a difference in performance. Now we are going to move on to our test results. Testing was performed with my Onritsu Cellmaster, a VHF UHF portable radio for the field strength testing, and a signal generator for the receive testing. The first test we're going to look at is return loss, and this is our original diamond, and it is easy to see that it exhibits good return loss at the lower end of the amateur 2 meter and 70 centimeter bands. Now we see our counterfeit antenna exhibits good return loss only at commercial split UHF. Pretty much lets us know right off the bat that this is not a dual band antenna. VHF SWR sweep of the original shows the antenna is tuned in the 2 meter band and has a very narrow bandwidth, as you would expect. VHF SWR sweep of the counterfeit confirms the return loss measurement. This antenna is not for use at VHF. It is a UHF antenna. UHF SWR sweep of the original diamond shows tuning in the lower portion of the 70 centimeter band with a narrow bandwidth, again, no surprises. UHF sweep of the counterfeit shows tuning at the lower end of the commercial split UHF band with a wider bandwidth than the original diamond, but still narrow enough to be consistent with the performance you would anticipate from a shortened vertical whip. The 1.2 gigahertz SWR sweep of the original diamond shows tuning at the very upper end of the 23 centimeter band. The 1.2 gigahertz SWR sweep of the counterfeit shows this antenna has no clue what it's doing up here. VHF transmit of the original, you see the field strength measured minus 24 decibel milliwatts per square meter. VHF transmit of the counterfeit antenna the field strength measured minus 38 decibel milliwatts per square meter. UHF transmit of the original was minus 15 decibel milliwatts per square meter, and UHF transmit of the counterfeit was minus 18.5 decibel milliwatts per square meter. Now the receive testing, or VHF receive of the original, was minus 67.48 decibel milliwatts, and the VHF receive of the counterfeit was minus 79.95 decibel milliwatts. UHF receive of the original was minus 54.26 decibel milliwatts, and UHF receive of the counterfeit was minus 54.43 decibel milliwatts. And here is the test data we captured in a spreadsheet format so we can compare. At the right of the spreadsheet is a variation column where you can see the positive variation of the data that favored the antenna that's listed in the best column. Well, after reviewing our test data there, it's obvious that there's nothing more than a UHF commercial split stubby antenna that's marked as a multi-band antenna. So I went ahead and I opened it up, and it wasn't that difficult to open up, and you can see that we are correct. And we have our housing here, we have our base, and then we have our element, and we have a little bit of insulation here. So I took that further apart, and we have our element, and we have our base, and it's kind of a cool base. It's got a hole in the middle of it here, and then this portion of our element here is wrapped around this threaded section here. So this is going to be pretty useful for different types of antenna projects. So what we have here is 9.5 inches of wire, excepting the portion of the antenna that's connecting to the base here, wound into a coil 9 millimeters by 16 millimeters long over 10 turns. So in conclusion, although this counterfeit tri-band antenna is not what it is advertised to be, it is still a well-constructed UHF antenna that could provide service as such. Should you purchase or come into possession of one of these counterfeit antennas, use due diligence and test the antenna before placing it into service for the bands it is advertised for. I hope this helps. This is Brett from SurvivalComms. Till next time.